All right, here we're going to evaluate some limits. So first one here, limit as x approaches 2 from the left of 5 over x minus 2. Okay, so obviously if I plug it in, I get a 0 in the denominator. Okay, so I'm going to have to, this is going to be some sort of infinite limit, but I have to figure out further. All right, so as x goes to 2, 5 goes to 5. X minus 2 would go to 0. Now we're coming at 2 from the left. That means we're coming like this, so like a 1.9-ish. That's going to leave a little bit of negative when I do 1.9 minus 2. So it seems as if I'll get 5, a non-zero constant over something going to 0. So I'm going to get an infinity, but I have a positive over negatives, so I'll get negative infinity. Okay. In B here, limit as x approaches 3 of this whole mess. Well, I'm going to try plugging it in. I would get 3 ln 3 minus 2 is 1 plus e to the 0 over 3 minus 1 is 2. So ln 1 is 0, so you get 3 times 0, that's 0, plus e to the 0 is 1 over 2. Okay, so I actually just get 1/2. And that's it. Okay, limit as x approaches negative 1 of the square root of x squared plus 8 minus 3 over x plus 1. Now notice if I plugged in x equals negative 1, I'd get square root of 3 minus, it was square root of 9, which is 3 minus 3. I get 0 over 0. Okay, so since I'm indeterminate, I have to do something. But this is where I remember to use my my radical conjugate. So I'm going to multiply by the radical conjugate. All right, again, on top, that's like an a minus b times an a plus b. So when I multiply that, I get x squared plus 8 coming out of the radical, minus for a squared minus b squared. And then I get the 3 squared, which is 9, over x plus 1 times this square root of x squared plus 8 plus 3 in the denominator. Oh, I forgot to put my limit in there, so that's a very bad thing. Luckily, I am able to manipulate mine here, and I can put that in. Okay, so now we keep going. This top is going to be x squared minus 1. So I'm going to get x approaches negative 1. I'm going to get x minus 1, x plus 1 over x plus 1 times the square root of x squared plus 8, all plus 3. And as I hoped, the x plus 1s would cancel. And so now when I plug in negative 1 here, I get negative 2. When I plug in negative 1 here, I get square root of 9, 3 plus 3, I get 6. So overall, I get negative 1/3. All right, limit as x approaches 2 from the right of this expression here. All right, so first I plug it in, and I see that on top I would get 0, and the bottom I get 0. So I need to do some more work here. I think I should try to factor a bit. So 5 times x minus 2 over x minus 2 x plus 2. So the x minus 2's do cancel. So I'll get the limit as x approaches 2 from the right of 5 over x plus 2. Now I try plugging in. I get 5 in the numerator and 2. Now I'm going to 2, not negative 2. So there's no issue of a 0 down there. I actually get 4 down there. So there we go, 5/4. Limit as x approaches 0 of 2x over sine 3x. Well, that looks like my special limit. Again, my limit as x approaches 0 sine kx over kx equals 1. But I'm going to have to do a little manipulation here. So I'm going to put 2 there, then I'll put the x over sine 3x, and then I notice I'm just missing the 3 to go along with that. So I could put in a 3 there, put in a 3 there, that's 3 over 3. So I haven't changed the problem. Oops. And now, when I take these limits, the limit of 2/3 is 2/3, and the limit of 3x over sine 3x, that's the special limit of 1, so I end up with a limit of 2/3. Okay, limit as x approaches infinity, 3x squared plus 1 over the square root of 2x to the 5th minus x plus 1. Okay, so what I've got is I've got a limit going to infinity, and I've got powers over powers. So on the top we have x squared. On the bottom, although it's more complicated than that, the bottom is of the type x to the 5/2. Okay, so because if I neglect this part here, then I would get the square root of 2 x to the 5/2. So I can use that as a basis of what power the denominator is. So the 2 on top and basically 2.5 on the bottom as exponents mean that the denominator dominates. So the denominator dominating is going to mean that this thing is going to end up going to 0. Okay, now how about the limit as x goes to negative infinity, 3x cubed minus 2x minus 1 over 5x squared plus 2x plus 3. Right, again, I've got a limit going to infinity or negative infinity, and I've got actually a rational function here, polynomial over polynomial, so this is again a battle of these powers. Now, clearly, the numerator is dominating here, so it'll be a type of infinity. But now I have to check the signs of my terms. I'm going to negative infinity. On top, the x cubed will still be negative. Okay, so I'm going to get negative numbers up there. On the bottom, x squared is going to be turned positive, so I get positive down there. So I have a negative over a positive, so I'll overall get a negative, hence negative infinity.